Hello, here Destin from B-Tips. In this lesson, I will show you how to design a decoder for a 7-segment display, and you would interface your first 7-segment display. So join me after the introduction. So there are actually two major technology of 7-segment displays. We have the common anode 7-segment displays and the common cathode 7-segment displays. Basically, the difference that we have between those kind of 7-segment, it's the way we have to turn on the single segments. So by the common anode technology, you have to send a logical low to each one of the segment. So you have to send them 0 volt to turn them on. And for the common cathode segment technology, you have to send a positive signal, so you have to send 5 volt or the high logical level to your pins or to your segment in order to turn them on. And the same goes also for the dot. So this technology that you see here is the one that we have on our Elbert V2 board, and we're going to be working with this technology. So regarding of the shape of the number that we want to display, we will decide if we want to turn on the E, the B, or whatever the segment we want to turn on. So based on that, we can then realize the truth table. We can realize our truth table, and for the DP, we have to set it on 1 for everyone because we know that we're not going to use the dot. And in general, when you design such a system, what you have to do is always to start with a small drawing. In your drawing, you will then have to you will then show your inputs and your outputs. And here we have 4 bits inputs, 7-bit outputs, and actually we only have 7-bit outputs because I already know that the 8th output is just set on 0, so it's set on 1. We don't need it. And inside this black box, what we have is our very truth table. So just join me to the next step to see how we want to realize this function. For that, we will have to switch to the Xilinx IDE, and I will show you line after line how we have developed the code. So here we're in the Xilinx. So we will go through the code line after line and see how the work can be done. So first thing is to import library IAE, use standard logic, all of that, and first thing we have to define is to define our entity, and the entity is actually the block that we have to send the black box. So we need to define the inputs and we need to define outputs. So I will start with line 34. Line 34 is actually showing us that we have an array because we want to display a 4-bit input. It's an array, so they call it vector, and I said that dip, and to say that it's an input, standard logic vector. So it's vector because it's an array, and the array is going from down, it's going from 3 down to 0. It means that we have 4 bits, so it's 4-bit input from the dip switch 5, 6, 7, and 8. And the next thing here is to go to the line 35, our output, SS. So SS is actually an output, as you can see it out, and it's also working on a standard logic vector, but here we're going from 7 down to 0. So it means that we have 8 bits. Why 8 bits? Because we have included to the 7 segment, we have included the dot. That's the reason why I've added this one. And we have some extra here that we haven't seen at the beginning. We have N, uh, I mean EN, we have EN1 and EN2. Why do we have those three? There are specific inputs that we have, outputs, sorry, that we have to define in order to command the 7 segment display to enable them or to disable some of them, because we only need a single 7 segment display. We're not gonna be working with all of them. So that's actually what we have on those lines, and it's standard logic. Now let's go to the architecture, and I will show you how you realize the functionality of your program, or sorry, of your module. So if you look at it carefully, you can see that it's actually the same thing as a truth table, but just put in another way. So let's try to go line per line. So I just transcribed the truth table, as you can see it, until F, and then I added an extra line, and this line, it's kind of safety, security 111, so everything will be 0, all the LEDs will be turned off. If you have combination that has nothing to do with what we're used to with the listed combination above, so it's just kind of a safety that I'm doing, you know, just in case a wire is broken. So what line 71 is saying is that we enable the third 7 segment. So now line 49, it's about with selection. So we select the input, and then we analyze each case of our input, and uh, we give some state to the output. So SS is the output. We then select the output. So if the input as this one, the output is gonna have that one. If the input is 001, the output is gonna be 1100111. That's actually the way that we have to read it. We start from the right and then we go to the left. So it's always kind of Arabic, you know. So if you guys are speaking Arabic or reading Arabic, it will be familiar to you. But it might be weird for people that are not used to Arabic. So, like value 0, we give it to EN2. That's the way that we read in the Arabic. But we don't want to take this part way too long for nothing. I hope that you guys have understood that in the architecture you have to read from the right to the left. So now what we need to do is to synthesize our code. We need to click on synthesize, and once synthesization is finished, we have then to go to the implement design. So in order to implement the design, and then if if the implement is working, it means that everything is all right. It means that the constraint file has been properly defined, so there are no error. It can then do the implementation of the circuit, and last step that we need to do is gonna be just to generate a programming file. Once you've So once we've generated a programming file, we can then switch to our programming desktop. We can then switch to the text board. Sorry, we can then switch to the desktop camera, text board camera. What's a weird word? So now we also have to look for the configuration tool in order to program all file. So here there's something very important to do is to make sure that you have the right port in order to find your driver. So now I'm looking for the project. Name of the project was 7 segment. I think 7seg sorry. So this one. Now I'm looking for the bit file. Hope that I can find the bit file. Maybe I should scroll up a bit. And now I should see, but my eyes are tricking me. But now I have it. So click on program. Now it's programming. Now we just have to wait a bit and then we can start testing our program.
So now we're on the workbench. You can see that the two first 7 displays are disabled. So 1 was actually standing for disable and 0 was standing for enable. So we third 7 segment display enabled, and now we can start testing our system. So if I push this one, we have 1, push it back and do so, 2, and if I push this one, 6, and we can have 7. If we want, we can also have 8, pushing them back, setting everyone to 0. No, did something wrong, didn't I? Oh no, so it should be this way and the other way around. It's a bit tricky because I have it. This one should be. So now we have 8. So sorry. This one is the. This one is the MSB, so the most significant bit, and that one is the LSB, the significant bit. Sorry. So I was saying, so this one is the most significant bit, and this one is the least significant bit. So, and we're running on an inverted logic because of the pull-up resistors. So here, if you have something facing on, it means that it's on 0, and if it's facing nothing, so off actually, it means that it's on 1. So now if I go back with this one, it'll be 0, and I put those 3 underneath, and we have 7. So that's it for this demonstration. We see that our interfacing of.
So that's it for the video. So if you like the content, don't forget to leave a thumb up and to subscribe, and also to share it with more people so that more people can take benefit from this. And also a big thank you for watching this video.